Hello everyone, welcome to Vuzzare Data Science channel. In this video, I will do exploratory data analysis for a data set which is present by default in Seaborn. So I've imported the libraries NumPy, Pandas, matplotlib and Seaborn. So now I'll import the data set. So data set you can import using sns.load dataset and the name of the data set is diamonds. So I've loaded the data set. Now I will solve these questions. So first I have to solve how to display the first 10 rows and the last 10 rows. So for this we will use df.head. So by default it shows 5 values. So we will pass it 10. It will show us the 10 values. So we have like values as so we have the column names as carrot, cut, color, clarity, depth, table, price, x, y and z. So we will do some more exploratory analysis, like we can also find the last 10 values rows by using tail. Also we have to identify data type of each column and identify missing values, and then we will identify like the values, unique values in each of the columns. So next we will do is the carrot has 53,940 not null values. All of them has 53,940 not null values. So I think it means that there is no null values present. And also we have to see the data type for each. So for carrot, the data type is float. And then we have three category data as cut, color, and clarity. So we will have to identify unique values in these cut, color, and clarity. And then depth, table, price. These are all float values. So these are numeric columns for our data set. So next we'll do is what we will do next is identify like data type we have already done. We can also use get it using like the tf.t types, so we can get the data type for each of these. Now we have to get the check missing values. So for missing values what we have to do is df dot is null. So this will show us missing values in each of the cells. Like carrot in the first row, they show false, but we are interested in knowing the count of that, so we'll use sum. It shows that in each of the columns how many are missing values, null values. So it shows that there are no null values presently in our data set. Now I have to do unique values in these columns, cut, color and clarity. So I'll use df and I'll use cut column and I will use dot n unique. This will show us the number of unique values in this column. So it shows 5 unique values are present in this column. So I will use uh, like to unique to find the unique values present in this data. It shows ideal, premium, good, very good and fair. These are the values which are present in cut column. Now the next column is color and clarity. So for color also we can do the same, color and what are the unique values present. So it shows E, I, J, H, F, G and D, like 7 values are there. And the next one is clarity. So the values in this are SI2, SI1, VS1, VS2, VVS2, VVS1, I1 and IF. So 8 values are in this column. Now we will solve some pandas problems. How to filter diamonds where price is greater than 10,000. So we have a column price and we have to filter the rows where price is greater than 10,000. So we'll use like filtered, it's a df and I've used price is greater than 10,000. So this will give us a boolean indexing, like whether it is true or false for each of the rows. Like if I run this, I will get like this, false, 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 true anywhere. And there are 53,940 rows, and we want to filter out like in which of the cases, rows this is true. So we will pass this condition, boolean indexing condition in the data frame again. So we will get rows in which the condition is true. So in all these the price is greater than 10,000. Like initially it was 53,000, now it is 5,000. If you use shape here, you'll find that the data set shape is now 5,000. So this was first question we did. Now how to select diamonds with cut quality of premium and color equal to E. Cut quality of premium and color is equal to E. So we have color is equal to E and cut is equal to premium. So we will have to pass two conditions in this. So we will use like data frame and we will pass two conditions in this, and we will join them using bitwise, like we will check using bitwise union, bitwise or. So first we'll check df, and in this we'll pass what the question was, cut quality of premium and color is equal to E. So we will give cut quality is equal to premium and color is equal to E. So we will pass in the data frame and we'll pass a condition here, color is equal to E, and we have already passed, we have joined, like we have filtered using this and condition. So like the thing is both will return values as boolean 1 or 0. So we cannot use and here, we have to use this ampersand sign here, and we will pass this into the data frame, our original data frame, and this will return as the rows. So you can see 2337 rows have been returned where this condition is true. Now the next question is how to create a new column for the volume of the diamond x into y into z. So we will create a new column called volume. So this will be like volume, and we will create it using x into y into z. So we can do like df x into df y into df z, and we will print like our df. It will return a new column, volume. So see, we have got a volume column here, and we can like do like make it round to 2. So df volume dot round to, and we will pass it into the same data series, and then we will see our data frame. So it will see like a volume column has been added. Now the next question is find the average price of diamonds for each cut category. So we have to find the average price for each cut category. Average price of diamond for each cut category. So we'll use df dot group by, and we'll pass cut here, and we have to find like price. So we'll pass on the, we have to work on the price column. So we'll pass the price, and we will use a function here mean, and it's a, let's say we'll name it as average price per cut, and we will print it like average per cut. So it will give us a data frame like this. So what we can do is we can do reset index, and we will get it in a form of data frame now. So we can see that for so we can see that for cut, different type of cuts, the average price has been shown. So the highest is for premium, which is 4584, and the lowest is for ideal, which is 3457. So this shows average price for each cut category. Next we will do top 5 most expensive diamonds and their details. So what we have to do is we have to find top 5 most expensive diamonds. So we will have only, so we will use sort values by price, and we will use ascending is equal to false. So this will return in the negative value, and we can use like sorted by price descending, and we can print like sorted, we can print the head of this data, so this will give us the top 5. So if we print the top 5, we can get based on the price, like these are the top 5 most expensive diamonds: 18,823, 18,818. Also, like if we do on our regular data set, if we do find the max of price, we can get using this like df and price dot max. We can find that maximum price is 18,823, which verifies this is sorting is fine. How to sort diamonds by price in descending order. This is a thing we have already done now. How to get the count of diamonds for each clarity category. So we have to get the count of diamonds for each clarity category. So we have a column called clarity, and based on that we have to get the count of each, like how many rows are there for each of the clarity category. So for this we can use df dot df, and we will pass the clarity column here, and we will use value counts. So this will give us the values. If we know value count, so we can get it like here like this. Also we can reset index for these, so now it will come like in the form of data frame. And let's say if we want to plot a bar graph, bar chart for this, we can also do that. So count for clarity. So this is our data frame now. Now next set of questions. How to group diamonds by color and calculate mean carat and mean price. So we will have to do two type of aggregation here. Group diamonds by color, and then we'll have to apply these mean carat and mean price. So for this we will do df dot group by, and we'll pass color here, and we will do carat, and we will pass price here, and we will do aggregation based on these. So for like we have to do mean only, so we don't need to do separate aggregation, we can do like this only. So we will get the mean aggregation for these, and we can do like round 2, so it will be rounded to 2 decimal places. and we can do reset index here like this. Also, like if you want to rename the column, you can rename here like this, rename, and it will have to be given a dictionary. So we will give the dictionary like carrot. So carrot will be like mean carrot, and price will be mean price. And if we run it, so we will make a variable color grouping, and we will print it color grouping. Oh, here we have to pass like columns. If we are doing for columns, we'll have to pass columns, and then we have to pass the dictionary. So this will be like mean carrot and mean price for each of the color groups. Now how to replace the cut category fair with average. So what we have to do is replace fair with average. So let's solve this question now. So first we'll see like category for cut we have unique values. What are the unique values? Ideal, premium, good, very good, and fair. So we have to replace fair with average. If we like do fair with, and if we store in a replaced df this, and if we see the dot unique values for this, we will find that fair has been removed and ideal, premium, good, very good, and average has come instead of fair now. Now the next question, how to drop rows where any dimension is 0 or missing. So already we have done like where how many null values are there. So we have seen that there are no null values. Also we can drop rows where like missing. So for this we can use like drop na, and we can pass the subset equal to x or y or z, and based on these we can drop from our data set. So if we see the data set size is same again because there are no null values in our data set. But if we had data set with null values, then we can drop null values like this df dot drop and a sub, and we'll have to pass the subset like based on which columns we have to drop the null values. Otherwise it will like if it finds null value anywhere in any of the columns in any of the rows, then it will drop the entire row. So we do not want that. We want to drop based on the x, y, and z column only. So we'll pass it as subset. How to rename the columns to uppercase. So for this, what we can do is we have df dot columns. So we have all the column names. What we can do is like for column name in df.columns. We can change it like column name dot str dot upper, and we can store it in this only. Frame again dot column, and we can print df dot columns. So now we get all the columns in uppercase. Now if we want to make it again lowercase, then we can pass it like this: df dot columns dot str dot lower. How to reset the index after filtering a subset of the data. So I've already shown you how to reset the index, like when we filter out, like anywhere we can filter out, and then we can do reset index and we can reset the index. How to calculate the price to caret ratio and add it as a new column. So we have to add a new column. So we'll add a new column, price to caret, and for this we'll use df price divided by df caret, and we will like round it to 2, so we'll pass it like this and then round it to 2. You can print it like this: price to caret ratio for each of the columns. Now we have to create a new data frame with diamonds having caret between 0.5 and 1. So for this we'll create a new data frame, filtered df. First we'll like filtered df is equal to df caret should be dot between. We'll use dot between here, and we'll pass 0.5 and 1, and this will create a boolean indexing, and we will pass it again to the data frame which we have, and we can print those like this. So I had to show like reset index, so we can do reset index on this, because you can see the indexes have started from 90 and they are ending on 53,000. So and there are total 18,000 rows only. So we can do reset index now. So now it will start index from 0, and see this previous index has been added, so we want to drop it. So we will write drop is equal to true. So now this column has been removed. Initially, like the previous index becomes the column in this, so we will remove that. How to do a conditional transformation? Apply a 10% discount on diamonds priced over 15,000. So for this we can use apply function. So we can use df dot discount of 10% on diamonds priced over. Let's say we can create a column discount, and we can pass it into like this: df dot apply, and we'll use lambda row, and we'll say discount of 10%. So we'll have row into price Or let's say we can directly pass here the price column, price, and we can have like our x. So x will be x into 0.1 if x is greater than 15,000, else we will have the normal value. So based on this we can print out df, so it will show how much discount it has been provided based on the price column. Else not x, it will be 0. So let's say the price is 326, so discount will be 0. And if let's say if we find a column where the price is greater than 15,000, for that we'll see the discount. So 15,000 is the price, we have got this much discount, so it is working. Now if we want to, like, we can drop these extra columns also, so we can like df dot drop column onto discount, will write in place is equal to true, and we'll print df. So we have dropped the column discount. Now we will see how to concatenate two subsets of timers. Example, platinum and ideal cuts. So we'll have to create a concatenated column. So we will create a concatenated column now. So df dot, let's say the name of the column is concatenated column, and we can do like df dot apply, and we'll use lambda, and here we'll pass a row because we have passed the entire series now, so we can pass it as row, and we will change the axis is equal to 1. So what we can do is row based on premium and ideal cuts based on, no sorry, we have to do concatenate here like merge, and we have concatenate where it like joins vertically. So first we'll make a premium subset, and we'll make it like df cut is equal to premium. So this will give us the premium data frame, we pass into data frame, and also we have ideal subset. This will be like df cut is equal to ideal and we will pass it again to the data frame, and we can see like the head for these. So all these will be premium. Similarly, we can see for ideal subset. So these will contain all ideal. And now we have to make a concatenated subset. So for this we will use pd.concat, and we'll have to pass both the data frames here. So ideal, and if we print concatenated dot head, so we'll see both of these. Let's say we can print the shape of this three, and we'll find like whether it is a sum of both or not. So we'll like print ideal premium subset dot shape, like print ideal subset dot shape, and print the shape of concatenated. So the first one has 13,700 rows, second one has 21,500 rows, and like the sum will be around 35,000, which is concatenated value. How to create a median pivot table to find median price by cut and clarity. So for this we can do pivot table, and we will have index as cut and clarity, and we will have columns as price, and we will have no values as price. So like we can do one thing, we can like pass cut as the index and clarity as the columns, and then values as price, and we'll use aggregate function as median. We'll print it. So we can see this based on like cut and clarity. So these are the cut, ideal, premium, good, fair, and very good. And then we have clarity, and based on these we have median values in the wide form, in a form of a pivot table. So we have done these. Now we will see the visualizations. What is the distribution of diamond carat weights? So we have to see the distribution of diamond carat weights. So for this we will see sns.histplot, because carat weight is a univariate column, and also it is a numerical column. So we'll create a hist plot, and we'll pass the data as df, and in x we'll pass carat, and if we plot it we'll find it like this. First, if you want like control the number of bins, we can pass bins is equal to 10, let's say. So we can say that mostly the values have value less than, like most of the values diamonds have like carat less than 25,000, carat less than uh, this value, which is let's say 0.7. If we create like bins is equal to 5, so we can see that 40,000 diamonds in our data set of around 93,000. 40,000 have they're like uh, in the range of this 0 to 1.2. So this has created bins. You can change the bins value according to yourself. So it is like very improbable to find, like very difficult to find a diamond with carat of, let's say, more than 3 or 4 or 5. How are diamonds distributed across different cut qualities? We can see count plot for this. So we'll sns dot count plot will pass the data as df, and we'll pass the x value as our cut, and we can plot the count plot. So we can say that ideal has higher number of values in our present in our data set, like 22, more than 20,000 rows have like cut quality ideal, and fair has like very less data presence in our data. What is the correlation between carat and price? So we have to find the correlation between carat and price. So for this, what we can do is we can plot a scatter plot, and in x we can pass carat, and in y we can pass price, and we will plot the graph. So like these are so many values, so it is like getting overlapped. Let's say we pass the hue as cut, so again like we had so much data points, so it is getting overlapped. What I can do is increase the size of this figure, plt dot figure size. Use plt dot show here. Like we again, this has so much data set, so it is getting overlapped, but we can see that as like carat increases, price is more or less increasing, but there's not a linear relationship. Like if it was at a 45-degree, we can clearly say that increasing the carat will increase the price, but it is like tending to increase, but it is after a certain point of time the price has reached the maximum value. Like after 2 carat, the price has reached the maximum value. Then we have to print the summary statistics of diamond prices. So for this, what we can do is df dot will apply on this price column only, and we'll use describe. So we will see the values like 53,000 are the total number of rows we have, and the mean is 3,932. Standard deviation is 3,989, and the median value is this 50 percentile, which is 2,401. Now we will see the next set of questions. How does price vary with cut quality? So we can see different type of cut quality are there. We have to see the price variation. So we can plot a box plot, and in data we will pass our data frame, and in x we will pass cut, and in y we will pass price. we'll see the box plot. So you can see like there are so many outliers in this data everywhere. So these are all points are the outliers. And if we can see like there's not much variation based on like cut, like mostly the ranges are in this only, less than 5,000 or around starts at around 1500 to 2000, and then the maximum is around 6,000 around that only. And a lot of outliers are present in our data set. Is there a trend of price with different diamond colors? So again we'll do the same thing, trend of price with different diamond colors. So what we will do is, based on colors we will plot a box plot. So color is a column name. So we can see that for D the price is very less, and prices normally varies a lot for I category, and also price is high for J category, and the variation is also very high. Also we can do one thing, we can create violin plot for this. So it will show us the data like this, how much are the outliers, and in between we have a box plot in the middle. So if I increase the size we can visualize it better. plt.figure.make size. So you can see the violin plot like this. Like in these we have a lot of outliers for D and E, and the broader it is at J and I, it shows less outliers, but still we have a lot of outliers. How does clarity affect diamond price? So for this, again we can do the same thing, df dot clarity dot unique, and we will print the unique values, and so we'll plot like sns dot box plot, and data will be df, and x will be clarity, and y will be price. So for like vs1 and vs2 we can see that the values are generally higher, and the variation is very less for if and pvs1, and the values generally tend to be lower, like 50% of them have a value, like mostly like 75% of them have value less than 2500, and based on this we can like make our as insights. What is the effect of depth percentage on price? So for this we can plot a scatter plot, depth percentage on price. We can do is df dot head. So we can create a scatter plot for this, because this is a again numerical column, and the other one which is price is also a numerical column. So x will be like depth, and y will be price, and we'll create a scatter plot. So it shows like data is cluttered between 55 to 70, and like the price is variable only, there's no clear relationship between these. Are there anomalies in diamond dimensions x, y, and z? Are there any anomalies in data dimensions x, y, and z? So we can find the anomalies using these are like outliers only. So we can do a box plot for these. We can create like columns is equal to x, y, and z. We can like create for column in columns, and we can like plot SNS dot box plot will pass our data, and we will have plotted on the y-axis, let's say price. X we will have our column name, and we'll have plt dot show here. So it is creating scatter plots for x and y and z. So we can see that for x, y, and z, it is like relationship is mostly shows the presence of relationship. Like if x is increasing, the price is increasing, and similarly for y and similarly for z, because it is like moving towards like a 45-degree angle, so it shows a kind of relationship. What is the correlation matrix between all the columns? So we have to find the correlation between all the columns. So for this we will use tf dot correlation, and we will use, by default it shows numeric only, so we will use correlation matrix, and we will print the correlation matrix. So we have the correlation matrix here like this, and we will plot it in a heat map now. So SNS dot heat map, and our data will be correlation matrix, and we will give the annotation as true, and we will format it as 0.1.2 f. Let's print it out. So our data frame looks like, our heat map looks like this. We can give the size plt dot figure fig size 12,8, and we can use plt dot show. So we can analyze a correlation based on this matrix. So the darker color shows less correlation here, and the white color shows more correlation because the minimum value is around 0.1 only, like minus 0.2. So also we can give a minimum, v minimum as -1. So now if the color is black, then it shows negative correlation, and if the color is red, it shows less correlation, and if the color is lighter, then it shows high correlation. Now we'll create these plots. Create box plot of price by cut and color. So what we can do is SNS dot cat plot, and we will use data is equal to df, and we'll pass the kind as box, and we'll pass x as cut, and we'll pass the y as price, and we'll pass the hue, which will be differentiated as color. So we can plot like this. If we are not able to identify anything based on this, so let's say we create a column based on this. Column for color, we'll do column wrap is equal to 3, so we'll have 3 columns in a one. So we have got our box plots like this for different colors. Okay, sorry, we'll have to pass a value as 3. So we will have 3 in each of the rows. So based on these, we can identify, like we have box plot distribution based on price, cut and color. For these are the cuts, and this is the color, and we have the price. Now we have to plot scatter plot of carat versus price with cut as hue. So we'll use SNS dot rel plot, and we'll pass data as df, and we'll have kind as scatter, and we will have carat versus price. So we will have on x-axis we will have carat, and on y-axis we'll have price, and we can have hue as cut, and we can print the image. But again, it will be an overlap because we have our data very overlap like this. So if we increase the size, we can get those. Last two are for you to do, but I will provide hints for these. So visualize the distribution of clarity categories using count plots. So you can create a count plot, and we will have like pass on the data, and then distribution of clarity. So we will have on the x-axis you will pass clarity, and just use count plot, you will get the value. And also we will have to use pair plot to visualize the relationship between numeric features. So use sns dot pair plot for that, and pass numeric only is equal to true, so it will print like only for the numeric columns it will show you the plot. So that is all in this video, guys. Thank you for watching. Do subscribe for more such videos.